In this lecture, we are going to talk about an application which I have developed on code.org using the basic features of Applab, with which we can prove Ohm's law very easily, according to which voltage is directly proportional to the current flowing in a circuit. The potential difference of a circuit is directly proportional to the current of the circuit if the resistance, provided that the resistance of the circuit is kept constant. So there are two different screens we guys will be using in this lecture for proving this Ohm's law. Now how can we make the resistance of the circuit constant? For that, what we have to do, we have to access the teacher's panel, or you can say the admin's panel. So for doing that, we have to hit this resistance over here.
You may set the resistance of all the circuits from here.
And automatically we are going to come across this beautiful screen. Fine. Now from here we can set the resistances of all the circuits. Now suppose there are two students who want to prove Ohm's law on these two different browsers using this app. So for doing that, what they have to do, they have to access the students panel first. So this is the second browser. I'm going to access the students panel on this one first. So this is how it looks like. Fine. So we need to input 5 different voltages on this students panel, and automatically we are going to see all the 5 voltages getting reflected over here in place of this V1, V2, V3, V4, V5. Let me show it to you. How can we do that? So for doing that, there is a slider kind of thing which I have defined over here. If you will slide it towards left hand side or towards right hand side, you'll see that the value of this label box is going to go change. Okay, it is changing. So let's first set it to 5. Okay, and then we need to hit this label box.
Done with setting the first potential.
So I'm done with setting the first potential. Let's now set the second potential to 10.
Done with setting the second potential.
Done with setting the second potential. Let's now set this third potential to 15.
Done with setting the third potential. Done with setting the fourth potential. Done with setting the fifth potential.
So I'm done with setting all the 5 potentials. Let's now come on that table kind of structure I showed you earlier. So for that, we need to hit this cell, and automatically we're going to get redirected on this beautiful table like thing. Fine. Now I am going to repeat the same step on this browser also. So first of all, I'm going to access the voltage panel, the students panel you can say, and let's set the potentials first. So right now, as you can see, V1, V2, V3, V4, V5 are visible to us on this table like structure. So let's set the first potential to 9, or let's set it to 15. Fine. Let's start for 15.
Done with setting the first potential.
So I'm done with setting the first potential equal to 15. Let's make it 25.
Done with setting the second potential.
Then 35.
Done with setting the third potential.
Let's set the last one to 45. Fine.
Done with setting the fourth potential.
Okay, I think one more is left, so we are required to set the last one too. So I'm setting it to 50.
Done with setting the fifth potential.
Okay, so I'm done with setting all the 5 potentials which are required over here in this table. Now let's set the resistances. Okay, so for doing that, we need to come on this teachers panel, and whatever I'm going to write over here, automatically the same thing is going to get updated over here in this column also, and on this column also. So it's a real-time application which I'm using right now. So this can be used by the teacher for setting the resistance of the circuits these two students are using. So I'm setting it to 5 at present. Let's hit the send button for setting the resistance.
Fix the resistance of the circuit to 5.
So as you can see, 5 is now getting reflected in all the rows of this column, and here also 5 is getting reflected in all rows. Okay, that's how we can set the resistance of the circuits these two students are using. Now what this student has to do, he has to write down his name over here. So I'm using this one for now, Abhinav, and here I'm going to write down the name of the second student, that is Samir. Now how can we calculate the value of current? So I have made use of a mathematical operator, that is slash, or you can say division, with which I am going to calculate the value of this currents over here. So for calculating the value of this I1, we just have to hit this label box. Likewise, we need to hit this one also. Okay, so because V is equals to IR, so it means that if you want to calculate I, then you need to divide the value of V with the value of R. So 5 divided by 5 is 1, 10 divided by 5 is 2, and so on. Similarly, we are going to calculate the values of this current for this circuit of Samir also. Okay, so we are done with calculating the values of this current part for this Abhinav circuit also, and for this circuit of Samir's also. Let's now hit this label box which I've placed on this beautiful image over here to check out whether it is going to give us a straight line or not in the curve.
Ohm's law states that the current flowing in a circuit is directly proportional to the applied potential difference and inversely proportional to the resistance in the circuit. In other words, by doubling the voltage across a circuit, the current will also double.
So as you can see, we are getting a straight line, okay, over here in this graph. Similarly, if you'll hit this label box which I've placed over this image here, this is what we are going to get.
Ohm's law states that the current flowing in a circuit is directly proportional to the applied potential difference and inversely proportional to the resistance in the circuit. In other words, by doubling the voltage across a circuit, the current will also double.
So it's a straight line which we are getting for this current and voltage curve that you're seeing over here, which means that the circuit on which Samir and Abhinav are working right now, they are following Ohm's law. Right, let's now go back. Here also I am going to go back, and let's now change the value to 10. Let's see what is going to happen.
Fix the resistance of the circuit to 10.
So as you can see, now the values of this part have got changed from 5 to 10, and here also you can see the changes. Okay, now let's find out the new values for this column. So we need to hit this label box. Okay, similarly we are going to find out the new values for this column also. So as you can see, we are done with finding out the values which are required for these rows over here. Now let's check out the graph, whether we are going to get a straight line or is there anything else we will get.
Ohm's law states that the current flowing in a circuit is directly proportional to the applied potential difference and inversely proportional to the resistance in the circuit. In other words, by doubling the voltage across a circuit, the current will also double.
Okay, so this curve is again showing that the circuit which Abhinav is using, it is based on Ohm's law. It is following Ohm's law.
Ohm's law states that the current flowing in a circuit is directly proportional to the applied potential difference and inversely proportional to the resistance in the circuit. In other words, by doubling the voltage across a circuit, the current will also double.
Okay, so this one is also following this Ohm's law, and that's how we can design a beautiful app with which we can prove Ohm's law very easily. Now let's check out the code I have made use of for making this beautiful app on code.org using the basic features of Applab. So this is the code, and let me show you the first screen. So this is not this one. This one is the first screen the user is going to come across when he will first access the app. Now if he will hit this resistance over here, he's going to get redirected on this panel where he can input a resistance. And similarly, if he will hit this voltage over here, he is going to get redirected on this students panel from where he can set the voltages of this cell. Fine. Now when the user will hit this send button which I have placed over here, this is a code which is going to get executed. So automatically a table-like structure with ID constant is going to get created on the browser connected to this app, where the resistance is going to get saved, and finally this whole code is going to get executed automatically, and we will get to see that resistance over here in these rows automatically. Okay, then it is the code for the slider which I have defined over here. So when the user will move this slider towards left to right hand side, automatically the number for this label box is going to get set. Now there is a counter variable I have made use of, the value of which I've initialized to 0 initially. Okay, now if it is equal to 1, so what is going to happen? Whatever, when the user will hit this label box, automatically the value of this first potential is going to get set. If it is equal to 2, then whatever value is getting reflected in that label box, it is going to come over here. Fine. Similarly, if it is equal to 3, then the third value of the label box is going to come here, and same thing is going to happen for the values for this 4 and 5 also. Okay. Now let's talk about what is going to happen if the user will hit this label 4. So where is this label 4? Let me show that to you first. So this I have placed a label box over this image, and the ID of this label box is label 4. So when the user will hit this label 4, automatically the value of x is going to go 0, and he's going to get redirected on this screen 3, where he'll be able to see this table-like structure. Now when the user will hit this I1, this is what going to get executed. So whatever name the user is accessing this panel, whatever name he's going to enter here in this input box, automatically a table with that name is going to get created on the data browser connected to this app, like the way you're seeing right now over here. So there were two persons I have take into consideration. The first one was Abhinav and the second one was Samir, and as you can see, there are two different tables which have got created over here, and the values of current and voltage is also getting reflected in this table-like structure. Fine. So this is the code which is going to get executed when the user will hit this I1 button, and same code I've defined for these 4 label boxes also, in order to calculate the values of current for these two different values of voltages and resistance. Fine. So likewise, we'll be able to get the required values for these two columns, that is voltage and current. And finally, when the user will hit this next button, he's going to get redirected on this beautiful screen where he'll get to see this chart-like structure, and the chart will be, he'll get to see the relationship between voltage and current getting reflected in a graphical format on this beautiful chart. Okay, so it's a line chart which I've made use of over here. If you want to customize this field, definitely you can do that. You just have to place 2 or more drop downs over here, and then you can connect those drop downs with these drops, okay, with these components, or you can say with these fields. And that's how I have designed this beautiful app. Hope you guys enjoyed this lecture a lot. Please do like and subscribe to my channel, and also share the link of this video in your group so that more and more students can come and join my channel and learn to code free of cost. In case you want to avail the coding classes facility, the new batches are going to start from 1st of the coming March. You guys are most welcome to avail the facility. You just have to ask your parents. Contact me, yourself registered to one of the batches which I'm going to start from 1st of March. Thank you very much for watching this lecture. God bless you all and have a great day. Bye bye.